In this problem, we need to solve the differential equation derivative of y with respect to x as equals to sine cubed x times cosine squared x plus x times e raised to the power of x. The given ordinary differential equation is separable because it can be written as dy equals to sine cubed x times cosine squared x plus x e raised to the power of x all multiplied to dx. Now we will integrate both sides to obtain integration of dy is equals to integration sine cubed x times cosine squared x dx plus integration x times e raised to the power of x dx. Let's consider the first integral as I1 and the second integral as I2. The integral I1 can be also written as integration sine squared x times cosine squared x times sine x dx, such that we can replace sine squared x with the identity 1 minus cosine squared x, and we are going to use the method of substitution by using cosine of x is equals to t and differentiating both sides to get negative sine x equals to dt over dx, or simply sine x dx is equals to negative dt, such that our integration now becomes integral 1 minus t squared times negative dt. Rearranging the terms, we have integration t raised to the power of 4 minus t squared dt. Using the power rule, we get 1 over 5 times t raised to the power of 5, 1 over 3 times t raised to the power of 3 plus the constant of integration c1. Substituting the value of t with cosine of x, we have 1/5 of cosine of x whole raised to the power of 5 minus 1/3 of cosine of x whole raised to the power of 3 plus c1. Now we compute the second integral I2, which is e raised to the power of x times x dx. We begin by considering e raised to the power of x as the second function and x as the first function, such that integrating by parts gives us x times integration of e raised to the power of x dx minus integration of derivative of the first function times integration of the second function whole integrated with respect to x, which gives us x times e raised to the power of x minus integration of derivative of x with respect to x will be 1 times integration of the exponential function is the function itself whole integrated with respect to x. And so that should give us x e raised to the power of x minus e raised to the power of x plus the constant of integration c2. Thus, integration of dy is simply I1 plus I2. So since we have obtained the values, we finally get y is equals to negative 1/3 cosine cube x plus 1/5 of cosine of x whole raised to the power of 5 plus x times e raised to the power of x minus e raised to the power of x plus c, where c is c1 plus c2. This is the solution to the given differential equation.